Yeah, I need a little sound here. All right, so what we're going to do is we're going to talk about activity 4.2.3, PWM, pulse width modulated signals. And there's a PowerPoint for this, and then there's the activity. I'm going to go through the PowerPoint first here, so let's take a look at that. And what they do is they start out with this in, they give you these 5 different waveforms here. And they say, hey, pretend that you got LEDs connected to these signals. And the frequency is the same between all these signals. It's just the duty cycle, the on time, that is changed here with these signals. And if you had an LED out there, if you take a look at the top one, you have 0 volts going out there right here. So there's 0 volts going out to that LED. And down here at the bottom, you've got 5 volts going out to the LED, so it'd be full brightness down here. And if you varied the duty cycle, the amount of on time, and they show you this one right here is a 25% duty cycle out of this period here, that amount of time, the actual brightness of the LED would be dimmer. And as you would increase it, working your way up 75% up to 100%, the brightness of it would change a little bit. So they're trying to get the students to understand pulse width modulation a little bit. And you know what, I'm pretty sure there's some pretty good videos. I always look up a YouTube video when I get to this section and run it for my students, because there'll be some good demonstrations on there for them. But anyway, that's what they're trying to get across to the students here. What is pulse width modulation? It's just changing the duty cycle, the amount of on time. And in our case, that then translates into a controller that controls a motor, and the motor will do some different things based on the pulse width. Actually, what's happening is you're trying to use like an analog signal. Even though it's digital, it's just 0 and a 1. You're just using the pulse width on here to act like an analog signal to change speed on a motor or change direction on a motor. Now, the MEMSIC device that I talked about before that comes in the kit, it's a MEMSIC 2125. What happens is it actually sends out a pulse width modulated signal, and the Arduino has to interpret that. So it can on those ports. And remember, if you remember the ports, looking back at it over here, they have the little squiggly lines on them. They're PWM. So there's certain of those digital ports that are PWMs. And this MEMSIC actually takes up 2 of those. And I'm not going to talk too much about the MEMSIC. That's one, it's in the activity. We'll kind of cruise through it, but you know, it's something for your students to work with. It's a different type of device. How can you use it? Well, the students can figure that out. I've had many of them actually interface it to the toll booth as the control switches. And that project that's coming up here, we call it Toll Booth 2. Alright, this is what I want to talk about today. I want to talk about this VEX 29 controller. And once again, this is a part that's going to come from, if you have POE being taught in your building, you're going to have to get friendly with the POE teacher and ask them if you can borrow some of their 29 controllers. You do have motors, because you have motors from the for the Copy Jam project and also the Toll Booth project you've done already. So the motors are 2 wires out of them, and what happens is this little device creates, you hook it up to the 2-wire motor, and this little device then can interpret pulse width modulation signals, and it will actually take that motor and it'll run it forward at different speeds based on the pulse width. It will also stop the motor. It will reverse the motor and have the motor go in reverse at different speeds. So it's kind of a neat little device. And what they want you to do is there's an activity where the students are going to hook up the 29 controller, the motor. They're also going to use the potentiometer. Of course, you could use either type if you don't have the VEX ones. You can use your other type of potentiometers that are available in electronics lab. And but that's what we're going to, I'm going to cover this in a separate video, actually going through and setting this all up. Here's a picture. If you take a look up here, they're kind of using the copy jam. They got the switches there. Here's your potentiometer. They got the motor on here. Where's our 29 controller? Should see a 29 controller on here. Yeah, this wire right here is a 29 controller. And the way you can tell, it's got a yellow lead, which is power, a black lead is ground, and then the white lead is the signal on that 29 controller. And they got that hooked up to it. And this is kind of nice, you know, the copy jam's got the motor in it and everything. So, but that's what I want to talk about next. I'm gonna do a separate video on that. So I just wanted to go through this PowerPoint. At least you got an idea what you're talking to with your students on it. And let me break out of this.